In this lesson, we're going to look at angles, how to name them, and how to measure them. So first, let's talk about how to name an angle. So an angle is going to be defined by its vertex. So the vertex of an angle is where the two rays meet. So in this particular angle, the vertex is point B. So the vertex, if we are naming with 3 letters, we're going to use the angle symbol, and the vertex has to be the middle letter. So to name this angle, we can name it angle ABC. And notice that B is in the middle because that's the point that they both go through. And the other way we can name it is in reverse. So we could name it angle CBA. So those two angles are the same angle. They are named with the vertex in the middle and then the endpoints of the rays on each side. So it can be named forwards or backwards, and it's the same angle. Since this angle is by itself, there are no other possible angles, we can also name this by the vertex only. So I could also call this angle angle B. But the important part here is that you can only use the single letter, the vertex, to name the angle only if it's the only angle. And in the next example, we'll see what that means. So here, since this is the only angle, and whenever I'm talking about an angle, I know that there's one on the other side, but whenever I'm talking about an angle, I mean less than 180 degrees. So I'm not really counting the one that is on the exterior. I'm talking about what is in between the two rays. So here is an example where there is more than one angle present. And that's when you cannot only name the angle by its vertex. Because if I say angle E in this one, there's many different options that it can be. So let's look at each individual angle and how we can name it. So there are some numbers in here and that can help me out. So first, if we are looking at the angle that goes from D to E to F, to name that angle, and I'll do that in green, this angle could be called angle DEF with E in the middle because it's the vertex. We can go in the reverse of that, angle FED. And then since there is this number in there, we can also call this angle 1. But we cannot call this angle E because there's something on the other side as well. So the next angle we can look at is on the other side. So it also uses angle or ray EF, but I'm talking about this one on the other side. So to name this one, we can start with the 3 letters. This can be angle FEG with E in the middle because it's the vertex, or angle GEF. And since it's numbered, I can also call this angle 2. The other angle that is in this picture is the entire angle. So that's going to be angle DEG. It goes all the way and it contains both little pieces. So I can call that one angle DEG, or I can switch it around and call it GED. Those are the only 2 names for this angle because it does not have a number that includes the entire angle, and I can't name it by its vertex because there are the 2 small pieces. So many ways that we can name an angle, and it doesn't matter what the order is as long as the vertex is in the middle. So that is if we're talking about the actual shape. The notation, whenever we're talking about how big the angle is, changes a little bit. So if I am talking about the measure of an angle, I'm going to put an M in front of the angle sign. So for this first angle, the measure of angle LMN, or any of those other names that we have, the measure of this angle is 70 degrees. So whenever we're talking about the measure of an angle, we put the M in front. So the regular angle is just talking about the shape and the existence of that angle. If we put the M in front, that's when we're talking about the measure, how big it is. So the measure of this other angle QRS is going to equal 70 degrees as well. So since we know that both of those are equal to 70 degrees, their measures are going to be equal. So measures are equal, and if we are talking about the angles without the M in front, if we're just talking about the angles, angle LMN and angle QRS, those are going to be called congruent angles. And so the symbol for congruent is an equal sign with this little squiggle on top, and that says that they are congruent. So it's important to distinguish the difference between which symbol you use in between them. Their measures are equal, the angles are congruent. So those symbols in that notation has to match up. The measures go with the equal sign, the regular angles go with the congruent symbol. So the next thing we're going to talk about are adjacent angles, and adjacent angles have a shared ray. So we don't have any names for the points here, we only have numbers to label each angle. So if we are talking about a shared ray, that means that there is a ray between them. So if I look at this one going from the vertex and out through this direction that I've marked in orange, the angles that are adjacent on that ray are angle 1 and angle 2. So I would say that angle 1 is adjacent, and I'm going to abbreviate that as ADJ. Angle 1 is adjacent to angle 2. If I look at another ray, so if I look at the ray that goes from the vertex out here, on this one, angle 2 would be adjacent to angle 3 because both of those angles share that ray in between them. So in this diagram of my numbered angles, the only angles that are not adjacent are angle 1 because it is made up of these two rays, and angle 3, they share a vertex but they do not share a ray. So angle 1 is not adjacent to angle 3. So with these, we have some different postulates that we can use. So the first one is the protractor postulate, which is going to be similar to the ruler postulate. So the protractor postulate says each ray is matched up with a measurement based on a protractor. So each ray is matched to a measure. And with that information, the measure of an angle is going to be the difference between the two measures that the rays are matched to. So just like the ruler postulate, if you look at the coordinates based on a number line or on a ruler, you would subtract those. Here we're going to do the same thing. So to find the measure of angle 1, which is the angle that's made up between these two rays, I am going to subtract and take the absolute value because measurements are positive numbers. So I'm going to do the absolute value, and I'm going to use one measure. So I can do the 110 minus the 70. Or I can do it the other way and I'll get the same answer since I'm using absolute value. So 70 minus 110. So no matter what, this is going to be the absolute value of 40. And absolute value is the distance from 0. So the absolute value of 40 is 40. The absolute value of negative 40 is also 40 because negative 40 is also 40 units away from 0. So no matter which way you subtract, as long as you're using absolute value, that will be the measure of the angle. So the measure of angle 1, and since I'm using measure, I'm going to say equals, and that's going to be equal to 40 degrees. The second postulate we're going to be working with is the angle addition postulate. So the angle addition postulate, similar to the segment addition postulate, is going to say that an angle, so the measure of angle A, B, C, and since we're going to be working with addition and an equal sign, I'm using the measure. So the measure of angle ABC is going to be equal to the sum of its two parts. So that'll be the measure of angle 1 plus the measure of angle 2. So if I know two of those pieces, I can find whatever the third is. So now we're going to put these postulates into practice. So first, we are going to use the angle addition postulate. So here it says find the measure of angle ABD, which is the entire angle. So we're going to get in the practice of writing out our theorem or our postulate and then using it. So based on that postulate, the measure of the entire angle ABD is going to be equal to the sum of its two parts. These are not numbered. They are measured, but they are not numbered. So I'm going to say the measure of angle ABC to show the one on the left, and then I'm going to do the measure of angle CBD. So if I add those two pieces together, I should get the measure of angle ABD. So once I have my postulate written out, then I'm going to substitute in what I know. So I know that the measure of ABC is 45 degrees, and the measure of angle CBD is 60 degrees. And then if I add those together, that'll give me the measure of angle ABD, which is 105 degrees. So we want to get into the practice of writing out that postulate and then plugging in our numbers. All right, example 2, this is going to use the protractor postulate. So the protractor postulate, we didn't have a postulate like a form to write it in, so we're just going to plug in our numbers because we have to have those coordinates. So to find the measure of angle BOC, I'm going to do the absolute value, and since I'm doing the absolute value, I can subtract it either way. So that's going to be the absolute value of 128. I like to put the bigger number first since I know I'm doing absolute value. So 128 minus 54. So if I subtract that, I'm going to be left with 74. And angles are measured in degrees. So the measure of angle BOC is 74 degrees. The next one we're going to look at is angle BOD. So for this one, the measure of the ray OD is at 180. And I'm going to subtract the measure of ray OB, which is 54. So if I subtract 180 minus 54, or I could do 54 minus 180 and take the absolute value, but that measure is going to be 126 degrees. So we can use the protractor postulate to find the measure of angles if we have some measurements. Example 3 is going to kind of be a compound example. So here we have a lot of information and it's drawn out for us, and we're going to mark what we know. So to draw this, the first thing it told us was that B is in the interior of angle AOC. So if AOC is our angle and B is in the interior, that just means that it is in the middle. The next thing says that C is in the interior of BOD. So that means that I need to draw ray D on the other side of C so that it will be in the middle. So that one comes out in this direction. Then it says that D is in the interior of COE. So I'm going to draw another ray on the outside of D so that D is in the middle of COE. So all of these were drawn based off of those descriptions. Then we are told that the measure of angle AOE, which is this entire angle, AOE, and that is going to be 175. So if I draw a arc that goes all the way across, and then I can bring it out a little bit so that I know what my measure goes to, this is going to be 175. So anytime you see this arc drawn all the way across, it's talking about the entire angle. Next, it tells me that the measure of angle COE, which goes from C down to O and then over to E, COE is 110 degrees. The last thing it tells me, and so the marking for a congruent angle instead of like a dash on a line segment is a little arc inside the angle. So the measure of angle AOB, so I'm going to loop that around, is congruent to the measure of angle COD, and that's congruent to, or equal to, the measure of angle DOE. So notice that this green right here does not loop all the way across like these others did. It's a little arc inside the angle, and that's what tells me that they are congruent. So now that we have this information, and it doesn't seem like a lot, but it actually is enough to figure out what each of these measures are. So instead of trying to work through this list, it might be helpful for us to look at what we have and look at what we can figure out. So if I have something where I have so much information that I need to find somewhere to start, sometimes what I like to do is to put in a variable. So what I'm going to do is these three little angle pieces that I've marked in green, the first thing I'm going to do is I'm going to label those as a variable. So I'm going to call each of these X. That's going to help me set up some equations to solve. So whenever I do that, what I notice is that I don't really have enough information to use this 175 degree angle because this is a big question mark. I don't have a variable listed there. But if I look at these two X's, those line up with this 110 degree angle. So I could find these by using my angle addition postulate. So since we have so much to do, I'm not going to write out the postulate each time here, but whenever I'm looking at COE, that is 110 degrees. Then I have that is going to be equal to the sum of its two parts. So the measure of angle COD is X, and the measure of angle DOE is X. So what this gives me is that 110 equals 2X. So if I divide by 2 on both sides, then I find that the value of X is 55. So each of these angles that I've labeled as X, I now know are 55 degrees. And that even includes the one that I didn't use. I can go on and label it as 55 degrees. So I used this statement right here that all of those were equal to find that they were all 55 degrees. So now I have those. Now I just went through and checked, and none of those are anything that it asked me to find here, but they were important information. And the first thing, now I can try to work through my list and see if I have enough information. The first thing it wants me to find is BOC. So to find BOC, I'm going to use the fact that the entire angle is 175 degrees. So I'm going to say 175 degrees, and that goes all the way across the angle. It's the one that was here in purple. And that's going to be the sum of all of the parts. So let's call this Y since we already used X. So that's going to be 55 plus Y plus 55 plus 55. So now I need to add those together, and I'm going to pull up my calculator. So since there's 3 of them, I'm going to use some of my math reasoning, and I need to add these 3 things together. Since there's 3, I'm going to do 55 times 3 to find what that sum would be. So this is 165 plus Y equals 175. So to find the measure of Y, I'm going to subtract 165 from each side. And that's going to tell me that Y is 10. So now I can go on and label this as 10 degrees. So this is a good time to talk about diagrams and that they are not drawn to scale. So this is going to be 10 degrees for the measure of angle BOC. Now that we know all of the individual pieces, we can find these other things by adding the parts together that we need. So BOD is going to be the sum of BOC, which is 10, and COD, which is 55. So 10 plus 55 is 65 degrees for the measure of angle BOD. The next thing is going to be BOE. So since we just found that BOD was 65, the only new part is going to be DOE, which is 55. And now I can add that together. So 65 plus 55 is going to give me 120 degrees. The last thing it wants me to find is AOD. So for AOD, I'm going to take AOB, which is 55. Then I'm going to add BOC, which is 10, and then COD, which is 55, to get those three angles together. So 55 plus 10 plus 55 is 120 degrees. So even though we were given what seemed like little information here, we were able to find all of those angle measures based off of those little pieces of information we were given in the beginning.